Alright, we are on lesson 43. So what I'm going to show you is how to find the exact area of the curve under the curve. We found an approximate, but now we can use some of the things we learned in the past to find the exact area. We're going to start off with example number 1. What we're going to do here is we have the equation y equals 2x. Now we're starting off with this straight line to show you that it works, because we could find the area of this by using simple geometry, because the shape is actually going to be a triangle. But we're going to start off with this line to show you that it works, and then we're going to do it with to find the area of curved objects, which we've not been able to figure out before. Alright, we want to find out what is the area of the line y equals 2x under the line from 0 to 2. Okay, so what we're going to do is I'll draw, first of all, a rough sketch of this. Okay, y equals 2x, it has an intercept, there's no plus anything, so the y-intercept would just be at 0, and then we would go up 2 over 1, sketch out my line. What we want to do is we want to find out what is the area of the curve from 0 to 2, which we see as a triangle, and we'll be able to figure out what that area is using simple geometry. We showed this process that this would work for curved objects. Now what we did before was we would split these up into so many rectangles, and the more rectangles that we drew inside of the triangles, the closer we would get to the answer. What we're going to do is, if we had an infinite amount of rectangles inside that triangle, we would find that we would get the exact area, because there would be no space left under it. Okay, if I draw just some small rectangles, we could see even small, if I drew maybe 10 to 20 rectangles, that there will be just a little bit of space, and we get even closer to an accurate answer. But what we are going to do is we're going to find out what would it be if as that approaches infinity, which we've learned about limits as certain things approach infinity. So what would the area of this be if the rectangles approach infinity? So what we did before is, if we had 2 from 0 to 2 and we split that up into, if it asked to split it up into 2 sub-intervals, we just take 2 divided by 2. To find that, we would have, each one would be the width of 1. But since we're doing an infinite, we're going to take that distance of 2, and we're going to divide each one up into what we're going to call n. Okay, and that's going to represent the width. Alright, like I said before, we would have a distance of 2, and we would divide that by 2, and each rectangle would have a width of 1. Remember, we factored out the width, okay, and then we multiplied it by each of the lengths. Alright, now the lengths, we got the lengths by doing this. When we put in x to get what the y would be, we would just substitute in what x is to get y, same as we do any function. Alright, so same thing here. What we have is we're going to start, each space is spaced out an even amount. So the first x that you would approach, we draw this a little bit larger, would be a space of 2 divided by n. Okay? And then the next space, it's even, so it would double. Alright, so this next space would be, if we were to figure out what x would be, it would be 4 over n. And then so on and so on. Okay? This would be 3 times this space, because I'm going over 1, 2, 3. So we do 2 over n times 3, which gives me 6 over n. Alright, so these would be all my x values. And what I'm going to do is put in, until I find a pattern, I'm going to put in my x to get, okay, x would be 2 over n. I'm going to put that into x to figure out what my y would be. So we have y is equal to 2. We're going to put that first x, the first split up into 2 divided by 2 divided by n, and we would get that would be, alright, actually the way they do it on the book, and this is good, is to make a chart like we did with graphing before. First x is 2 over n, we put that in, and we would get then 4 over n Back up a little bit. Actually, the first one I should have used